సో ఇప్పుడైతే నేను చెప్పా కదా, నెక్స్ట్ వీడియోలో కంటిన్యూ చేస్తానే, అది వచ్చేసి పర్ఫార్మెన్స్ అనాలిసిస్. సో వాట్ ఈస్ దిస్ పర్ఫార్మెన్స్ అనాలిసిస్ అండ్ డీటెయిలీ ఐ విల్ ఎక్స్ప్లెయిన్ అబౌట్ యూ. సో let us start. So here the performance analysis is nothing but an algorithm may not have some performance for different types of inputs. With the increase in the input size, the performance will change. Algorithm will not have any performance same. It has different types for different types of inputs. So with the increase in the input, if input is increasing, then the performance will change. Yes, that's it. So it says that one. So an algorithm may not have the same performance. Algorithm, whatever is there, it will not have any same performance. When the input will changes, it will also differ. So with the increase in the performance, with the increase in the input size, the performance will change. Then performance analysis of an algorithm depends on the two factors. It depends on the two factor algorithms of the performance. So performance algorithms has two types, which is nothing but the space complexity and time complexity. So here is a space complexity, and here is a time complexity. So space complexity is nothing but the amount of memory used by the algorithm to solve a given problem. So if suppose 2 plus 1 is here the amount of memory used by the algorithm. So assume I am my algorithm. Okay, the amount of what I'm using my memory to solve this 2 plus 1. So my memory is nice only na, then I'll write 3 na. So here the amount of memory used by an algorithm, whatever the algorithm uses its memory to give the solution to solve the given problem, which is called as space complexity. Okay, understood? So it's nothing but the very easiest thing only. Okay, next one is the to estimate memory requirement, we need the focus on two factors. Again, if you want to estimate the memory, if you want to see the memory requirement, it has two part, fixed part and the variable part. Fixed part is nothing but it is an independent on the input size. Whatever the input size is given, it will not depend on it, and also it includes memory for the code, constant and variables. That's it. Okay, whereas variable part is nothing but it depends on the input size. Here it will not depend, here it will be depending, and it includes the memory for recursion stack, referenced variables, etc. Okay, understood, I hope. So space complexity is nothing but whatever the memory used for the algorithm to solve the particular problem, given problem, and it is called as space complexity. It will have the to estimate any memory requirement, it has two parts, which is fixed part and the other is variable part. What is the fixed part means the whatever the it is independent on the input size, whereas variable is depend on the input size, and also it is includes memory for code, constants as well as variables, whereas it includes memory for recursion stack, referenced variables. Next one is we have some examples you can see has here. If you wanted to note down it, you can note down. Okay, this is example 1. Yes, I hope you can able to see this one is example 1 and the other is example 2. Next is time complexity. So what is meant by the space complexity? Just now we have understood that is we have any algorithm, the memory of the algorithm to solve any problem, which is called as space complexity. Whereas here their memory required means here time required. In the definition it is itself saying that it is time. So that's why time required here. Time required for an algorithm to solve the given problem, it is called as time complexity. Okay, next, need to concentrate more on time complexity, because solving space complexity is easier than time complexity. So you can write it as space complexity is easier than time complexity. To estimate the time complexity, need to consider the cost of each fundamental instruction and the number of times of the instruction is executed, how many times it is executed, and also what is the need. Fundamental instructions of the cost also is the important here. So you can write this one. And also we have representation, which is t of n is equals to t into n. Yes, that's it. And here is again the simple example of this one. I hope you can note down this as well as this. So two examples are given. And yes, so here is the space complexity. Whatever I did, I'm giving is revising them once again. Space complexity is nothing but whatever the memory used for the algorithm to solve any particular problem, and also it estimates the memory requirement. So to estimate any memory requirement, we have two types, which is fixed part and the other is variable part. What is the fixed part? It is nothing but it is an independent of the input size, whereas the other variable part depends on the input size and also includes for the memory of the code, constant variables, etc. And it includes memory for recursion, stack, referenced variables. Next one is the space complexity, will be representing like this, both of this. And other is the time complexity. In the time complexity, what we have learned, that is time is required by the algorithm to solve any particular problem, and also need to concentrate more on the time. But as far as, because solving space complexity is easier than the time complexity, to estimate any time complexity, need to consider the cost of the fundamental instruction as well as the number of times of the instruction is executed. Here are the examples. Okay, in the next video, let's learn about the order of the growth. Okay, I hope you have understood this video, and I will continue this one in the next series. And like, share, subscribe. Thanks for watching.